In Adelaide, property owners are being told something unusual about the ground beneath them. They can keep living and working at the surface, but from 10 metres down, the government may need to acquire the land below. The reason is a road so large that the only practical place left to put it is underneath the city. 3 tunnel boring machines, each about 15 metres across, 100 metres long, and weighing roughly 3,500 tonnes, are being prepared to carve twin motorways beneath Adelaide's inner suburbs. They will run around the clock, passing below houses and businesses while life continues above. And together, they form the most dramatic part of a $15.4 billion attempt to solve a problem Adelaide has been wrestling with for more than half a century. It is called the River Torrens to Darlington Project, or T2D. On paper, it is only 10.5 kilometres of new motorway. In reality, it is the missing link in a 78-kilometre north-south route between Gawler and Old Noarlunga. Finish this one section, and Adelaide finally gets a continuous, traffic light-free motorway across the metropolitan area. But this final gap runs through some of the city's most developed suburbs. There are homes, shops, tram lines, utilities, heritage places, and one of South Australia's busiest roads directly in the way. Building at the surface would tear apart entire communities. Building above them would create another enormous barrier through the city. So engineers chose the least visible option, and possibly the most difficult. They would put most of the missing motorway underground. If you're enjoying this look inside the engineering, subscribe to Mega Projects. It helps us keep making stories like this. The government says drivers could bypass 21 sets of traffic lights and save as much as 40 minutes in peak traffic. Critics see a different number, $15.4 billion, for a road whose early economic assessment returned less than $1 of conventional benefit for every dollar spent. So, is Adelaide building the road that will finally unlock the city? Or burying one of Australia's most expensive transport gambles beneath it? To understand the obsession with this final gap, look at Adelaide's geography. The city is squeezed between the coast and the Adelaide Hills, while much of its population growth has stretched north and south. Jobs, the airport, Port Adelaide, and major industrial areas all depend on a transport network trying to funnel movement through a narrow urban corridor. South Road carries the burden. More than 120,000 vehicles use South Road and its parallel routes, Marion and Goodwood roads, on an average weekday. On the unfinished section, commuters mix with delivery vans and heavy freight. Cross-traffic fights for the same space. During the day, parts of the route operate with almost no spare capacity. The rest of the north-south corridor was upgraded piece by piece. Expressways, underpasses, elevated sections, lowered motorways, and major interchanges. 67.5 kilometres were already complete when planners reached the central problem. Every finished section made the missing 10.5 kilometres feel more obvious. The new design is not one endless tunnel. From the south, twin 3-lane tunnels will run roughly 4.5 kilometres from Clovelly Park toward Anzac Highway. They then emerge into a lowered, open motorway through the middle section, with connections toward the city, airport, and major east-west roads. Farther north, another pair of 3-lane tunnels runs about 2.2 kilometres toward the River Torrens and the existing motorway. The old South Road does not simply disappear. Where the motorway is underground, the surface road remains available for local traffic. The fast, long-distance movement is separated below. Local access stays above. It is an attempt to give one corridor 2 different jobs without widening it into a scar across the suburbs. Now comes the difficult part. Engineers have to drive enormous parallel bores through changing soil and groundwater, install a permanent concrete shell as they advance, and do it without damaging the city sitting overhead. Adelaide has never operated machines like these before. By the end of 2026, the plan is to have 3 of them digging at the same time, an Australian first for a major road project. The machines are named Mary, Catherine, and Elizabeth, after South Australian suffragists Mary Lee, Catherine Helen Spence, and Elizabeth Webb Nichols. The names may sound gentle, the machines are anything but. At the front, a rotating cutter head the height of Adelaide Oval's goalposts attacks the ground. Behind it stretches an underground factory packed with motors, conveyors, hydraulic systems, electrical equipment, and crews. Up to 20 specialists can be working inside one machine while it advances. The first two machines launch from Clovelly Park and excavate the parallel southern tunnels. The third launches farther north at Richmond and builds both northern tunnels, one after the other. Running 24 hours a day, each machine is expected to progress about 8 to 10 metres daily. At that pace, passing beneath a single property may take around 3 days. Every metre creates two jobs at once. First, the cutter head breaks away the ground. Conveyors carry that excavated material, known as spoil, back through the machine and out of the tunnel. Then, a mechanical erector lifts 10 precast concrete segments into place, creating a complete ring around the new cavity. Hydraulic cylinders press against that finished ring and push the entire machine forward. Excavate, build, push, repeat. This is why a tunnel boring machine is more than a giant drill. It leaves behind the structural tunnel as it moves. The shell must resist soil pressure, groundwater, traffic loads, and decades of vibration. And its position has to remain extraordinarily precise. A small steering error, repeated over several kilometres, would become a very large problem by the time the machine reached its destination. The main tunnels are only part of the underground network. Two smaller machines, each about 4 metres in diameter, will excavate cross passages between the northbound and southbound tubes. These links appear every 120 metres. They carry operational equipment, give maintenance crews access, and during an emergency, provide drivers with an escape route into the unaffected tunnel. By the time the excavation is finished, the project expects to have produced roughly 8 million tonnes of spoil. That is not simply a digging problem, it is a logistics operation measured in years of conveyors, stockpiles, testing, covered loads, and truck movements, all while South Road must keep functioning above. The smartest machine in the world still has to obey the ground it meets. Along this route, conditions shift from soil to rock, with groundwater pushing into every weakness. Investigators drilled hundreds of boreholes and tested thousands of samples before construction. Even then, the final truth only appears at the cutter head. Groundwater is the quieter danger. The tunnels need seals, drainage, and pumping. But remove too much water and the ground above can settle. Engineers, therefore, have to control the water below while monitoring movement at the surface. Properties along the route are offered condition surveys, and sensors track vibration and ground movement in real time. Officials say the machines should remain well below levels that could cause structural damage. That promise matters because the route passes beneath private property. The government is acquiring underground land from 10 metres below the surface, while leaving ownership above that depth intact. Without the tunnel alignment, officials estimate that roughly 300 additional homes and businesses would have faced acquisition and demolition. Yet hiding the motorway does not make its construction invisible. 3 huge surface precincts are needed to assemble and launch the machines, build portals, process materials, and support a 24-hour operation. Acoustic sheds are designed to contain noise around the tunnel entrances. Haul routes are being strengthened. Utilities must be moved. Even the Glenelg tram overpass at South Road had to be rebuilt to make room for the lowered motorway beneath it. Power is another challenge. 2 dedicated substations were built for the project. One supplies Mary and Catherine in the south. The other supplies Elizabeth in the north. Each has capacity comparable to the demand of about 5,000 homes. Once construction ends, that electrical infrastructure will stay, powering lighting, ventilation, traffic control, and safety systems inside the tunnels. And safety underground has to assume that something eventually goes wrong. Cameras and automatic incident detection will watch the motorway. Variable signs can close lanes and reduce speeds. In a fire, jet fans control the direction of smoke. A water deluge system attacks the flames, and drivers can be directed through the cross passages into the opposite tunnel. That second tube becomes both an evacuation path and an access route for emergency crews. The engineering is designed around failures everyone hopes will never happen. The political argument begins with something unavoidable: the bill. How do you decide whether 10.5 kilometres of motorway are worth $15.4 billion? The bill is divided equally between Australia's federal government and South Australia. It is the largest infrastructure project in the state's history and is expected to support about 5,500 jobs per year during main construction. The program also includes $850 million for surrounding roads, walking and cycling links, landscaping, and local improvements. But the project also requires land at the surface. The 2022 design identified 524 full or partial property acquisitions for portals, open motorway sections, relocated services, and construction areas. Some are homes, some are businesses. A tunnel can protect hundreds of buildings along its path, but it cannot eliminate disruption where it enters the ground. Then comes the disputed part: what Adelaide receives in return. Infrastructure Australia's 2022 evaluation put the conventional benefit-cost ratio at about 0.7. Count the expected savings in travel time, vehicle costs, safety, and similar benefits, and the total still fell short of the assessed cost. Broaden the calculation, and the answer changes. Include expected urban development gains, and the ratio rose to 0.9. Include wider effects on businesses and productivity, and it reached 1.2. Judge the entire 78-kilometre corridor as one completed program, rather than this final and most expensive gap alone, and it reached 1.31. In other words, both sides can point to an official number. Critics see a project whose direct benefits struggle to justify its price. Supporters see the missing link that unlocks value from every section already built, improves freight access to the port and airport, and turns an unreliable peak-hour journey into a predictable 9-minute trip. There is also a hard limit to what a tunnel can solve. It can remove 21 traffic lights from this journey, but every vehicle still has to enter and leave somewhere. If surrounding roads and interchanges cannot absorb the flow, Adelaide could spend billions moving congestion rather than eliminating it. That is why the broader network upgrades and traffic management systems are not side projects. They are part of whether the central promise works at all. T2D is not a simple contest between a good road and a bad road. It is a choice between competing risks. Build the final connection at enormous cost, or leave the most congested gap in a motorway system that is already almost complete. As of mid-2026, this is no longer a project that exists only in renderings. Surface construction is underway. The dedicated substations are live. The first giant machine, Mary, has been assembled, blessed, and commissioned at Clovelly Park, with Catherine and Elizabeth expected to join the excavation before the end of the year. Tunnelling itself is expected to take up to 2 years. After the machines finish, crews still have to build the internal road decks, connect ramps, install ventilation and safety equipment, fit the intelligent motorway systems, test everything, and restore the surface. The complete T2D route is scheduled to open to traffic in 2031. If it works as planned, a driver will enter a portal beside the suburbs and travel through a 6-lane underground motorway while ordinary life continues above. People sleeping, shops opening, children walking to school. Freight that once stopped repeatedly on South Road will move through without a single traffic light. The last missing link will connect a continuous route stretching 78 kilometres across Adelaide. But the true test will not happen on opening day. It will come years later. Did travel times remain reliable? Did local streets become quieter and safer? Did the open spaces and surface upgrades reconnect communities? Or did the portals and interchanges simply move the barrier? And did the economic gains justify the largest infrastructure bill South Australia has ever accepted? Cities rarely get the chance to rebuild their main arteries without changing the life around them. Adelaide's answer is to separate those worlds, to keep local streets at the surface and send the fastest movement deep below. It is technically elegant, financially controversial, and impossible to judge by the tunnels alone. Because this project is not really about digging a road, it is about whether a city can buy back time without surrendering the neighbourhoods in its way. By 2031, Adelaide may finally have the non-stop motorway imagined for generations. The traffic lights will be gone, the giant machines will be dismantled, and $15.4 billion of engineering will be hidden where almost nobody can see it. The machines may settle the engineering challenge underground. The argument over whether it was worth the price will remain at the surface. So if Adelaide handed you $15.4 billion, would you finish South Road this way or invest the money somewhere else? Tell us below and subscribe to Mega Projects for more stories where engineering, money, and ambition collide.